Next, we're going to take a look at domain. So what I usually think about when I'm trying to find the domain of a function is what can I legally put in for x? Another way to look at finding the domain is what can't I put in for x? What restrictions are there for this function? For our first function, we have it in a set of ordered pairs. This should probably be a regular parenthesis. So the domain is your x value. So for this function, our domain is 0, 1, 2. That's it. We can just list out the x values. For the second one, again, I usually think of it as what can't I put in for x. So in this case, what my function is doing to my domain or my inputs is squaring them and then adding 3. Are there any numbers that I can't square and then add 3 to? The answer is no, so the domain in this case is all real numbers. Part C, we have a value under a radical. Well, we can't take the square root of a negative, so my domain would be what's under the radical must be greater than or equal to 0. We can take the square root of 0, so that is part of our domain. So I'm going to solve for x, and my domain is all x values such that x is greater than or equal to 5. For part D, we have potential division by 0. So that's going to be our domain restriction on this one. Whenever you see a fraction bar, look for division by 0. So you have a couple of different options on this one. You could set x squared minus 9 equal to 0 and solve by undoing. Typically what happens is students will lose the negative answer when they take the square root. So maybe a safer route would be factoring. Difference of squares, we got our conjugates. So we'll set both of those pieces not equal to 0 to find our domain restrictions. So in this case, x cannot equal positive or negative 3. And finally, we have this big mess of a function for part E. We've got a radical in the numerator, so we have to look out for taking the square root of a negative. And we've got a denominator, so we have to look out for division by 0. So we're going to look at one domain at a time and then put them together to make sure that they're both okay. So numerator, setting x plus 6 greater than or equal to 0. So x needs to be greater than or equal to negative 6. When we look at the denominator, 6 plus x cannot equal 0. Therefore, x cannot equal negative 6. So when we put these two domain restrictions together, our final domain is x must be strictly greater than negative 6. Because if we put negative 6 in, yes, the numerator would be okay, but the denominator would give us division by 0.